Welcome to the AEM 251 lab. Today we are doing the bending in beam experiment. So let us start the experiment by switching on the universal testing machine. And let us go ahead and double click on TW Elite, which is a software. First thing which you need to do is you just go to File, go to Open Test and load any tension test. That's all we need to do as far as the software is concerned. So I'll just make sure that it's on. So once that screen pops up, I can see load, cross-head, extensometer, time, stress and strain. All those things are not required. Only thing which is important to us for this experiment is the load. So your first step will be to go ahead and re-zero the load. So right click on it and click zero signal. That's gonna zero out our load. Okay, we are gonna do the bending in beam experiment. So as the name suggests, so our aim today is to take this beam which has a rectangular cross section, and what we will do is we are gonna see how the bending stress varies along the cross section of the beam. So that is our main objective. So in order to find out what the bending stress is along the various cross section, so what we would do is we have a lot of strain gauges on the surface of the beam. You can see there are 3 gauges on this side, 1 on the top, 1 on the bottom and 4 on this side. So what these gauges do is, these gauges help me to measure the strain at various depths in the beam, or rather at various locations in the beam, and once we get the strain we can readily find out the stress. So that way we are going to find out how the bending stress changes, or what is the variation of the bending stress along the cross section. Okay, and we are going to find this out from the experiment which we will do today, and also we are going to find it out from theory. We have a total of 9 gauges, and these strain gauges are exactly similar to the strain gauges which we used for the Poisson's ratio test. So since we have 9 gauges, we need 9 channels in the strain gauge indicator, that is these blue boxes, to measure this strain. So what I'm going to do is I'm going to set up this beam first in this frame over here, then explain to you about the frame a little bit, and then I'm going to come and show you the strain gauge indicators. Okay, so firstly just take this beam and place it on the supports very gently. Okay, place it on the supports very gently, and then we will see that whether this beam is positioned properly. So this is the bottom part of the beam, so I need to flip it. So basically you just flip it, and the top and the bottom are mentioned over here. It's written with the help of a marker, so you can readily look at it. Okay, once you position the beam, make sure that it is symmetric. So right now the beam is set into place. My next task will be to check out my strain gauge indicators. Like I told you, we have a total of 9 strain gauges, so we need 9 channels. So you know that each of these blue boxes have 4 channels, so 4, 4 and 1, so we need a total of 3 boxes. Okay, so let us start by seeing the configuration of the boxes. So let me first press on the first box, and we can see that the box kind of gives me garbage value, although there is no load right now. So firstly I'm going to check whether the box has proper gauge factor and has a proper bridge type. So the very first thing which I'm going to do is press the bridge button, and you can see that all the channels are quarter. Okay, so we need quarter gauge for this experiment. Okay, so if you press this button, it moves to other type of bridges, but we won't worry about that. We will just make sure that it's quarter. So once that is done, what you do is you press menu again, and we are going to see what the gauge factor is. So press this button, and you can see that the gauge factor is 2.145 for the first channel. Okay, just press this button and just see whether it's the same for all the other channels, because it's going to be 2.145 for all the channels. So I see that it's the same for all the channels. That means I am good. So I'm going to press the menu button again, and next what I'm going to do is I'm going to go ahead and balance the strain gauge. So once I press balance, just press record again, and then you will see that all the strain gauges have become 0, or rather close to 0. Okay, so this is how we try to take care of the bias associated with the strain gauge. Next, I'm going to move to the other strain gauge, where the other channels are connected. So the first 4 channels are connected to this strain gauge we just saw, and in this strain gauge, channels from 6, 7, 8 and 9 are connected. So what about 5? We are going to come to 5 later on, but let's first check if this is perfect. So let us press this, and we are seeing that the gauge factor is 2.145. so all the gauge factor is like 2.145. then let's press on the menu again, press on the bridge, it's all quarter, so I'm good. So again I'm going to press balance. Okay, so everything is good to go, and I'm going to press balance and then press balance again, and that's going to balance out our gauges. It's going to fix the bias. Then click on record, and that's it. So it should balance out my gauges. It should be as close as 0, if not 0. So once you see a value which is close to 0, you should be good. Now coming back to the fact that we did not attach the 5 gauge. So actually my 5 gauge is, the 5th gauge is attached to this particular let me go ahead and take the handheld remote so that I will be able to control the load quickly. So I'm just going to press this key, which is green, which when it turns green, that means my setup, my remote is active. So now if you see the load on the computer, it reads 0. So if you see the manual on your computer, you will see that the manual will give you a table where you need to fill in the data. So the very first thing which you need to do is, before we move any further, is to first go ahead and record the data for the 0 load. Right now you can see that it's 0, so we are going to record whatever strain gauge readings we have for 0. So right now we are at 0 load, and the gauges read, I'm going to call out the gauges like 1, 2, 3, 4, then 6, 7, 8 and 9, and then 5. We won't worry about it right now. I'm going to tell you in a moment why 5 is not that important. So the first gauge reads -7, the second gauge reads 0, the third gauge reads +6, the fourth gauge reads +3, the sixth gauge reads -4, the seventh gauge +2, the eighth gauge +1, and the ninth gauge +4. And the fifth gauge does not read anything, so we are going to worry about it later on. So now your next step will be to go to 200, which is your next data point. So you're going to have to bring that head down really slowly. I recommend that you use the coarse displacement button first. So we are trying to bring it down, but don't let the loads touch the beam with this button, with the coarse displacement button. Bring it as close as possible to the beam. Okay, so once you have come very close to the beam, switch over to the fine button. Okay, so let's start it. So I'm starting to bring the head down really slowly, so you can see the load will increase in a moment. So you can see that the load is increasing. Don't worry about the negative sign, it is just convention. We're going to take it up to negative 200. So we are at 200. Now we are gonna see what the gauges are. So the first gauge reads -330. The second gauge reads -149. The third gauge reads -149. The fourth gauge reads -50. The sixth gauge reads +85. The seventh gauge +145. The eighth gauge 244, and the ninth gauge 313. So you can see that the first four gauges are positive. Sixth gauge, the gauge readouts are positive. Now why is it so? Now if you imagine, so when I am putting a point load on the beam is bending like this. Okay, and the region over here is the neutral axis. Okay, so anything above the neutral axis will have compression. That means it will have negative strain. So the first four gauges is in the compression zone. So the gauges read negative, and the other gauges, that is the 6th through the 9th gauge, is in the expansion zone, that is beyond the neutral axis, towards the bottom of the neutral axis. So it is stretched out, so it has a positive strain. Now as far as the 5th gauge is concerned, so the way this beam has been set up, and you can see the cross sectional diagram in your manual as well, the 5th gauge has been placed in the neutral axis. So ideally the 5th gauge should be 0. Since we do not have a readout of the 5th gauge as of now, so just consider the 5th gauge readings to be 0, because the 5th gauge has been placed at the neutral axis. So ideally it should be 0. So we will consider the ideal case that the 5th gauge is at the neutral axis, so that will be 0. So that way, continue this. So increase the load to 400, 600, then 800, then 1000, like it is laid out in your manual, and record the strain gauges, and then come back to 0 again gently, and then record the strain gauges again at 0, because you want to get the 0 reading before and after the experiment, because that will kind of help me to grossly estimate the error. Okay, so once you do that, the data collection for this experiment will be complete, and from the data we are going to plot the distribution of bending stress along the cross section, and I'm also gonna we also want to try to find out the bending stress distribution from theory, from the geometrical configuration. One last thing before we end this video is, don't forget to measure the cross section of the beam, because that is very important for your calculation. You need to know the dimension of this cross section.